Hey guys, I'm going to show you an example how to solve a matrice. I have these two linear equations, 2x minus y equals 8, x plus 3y equals 11. This is the matrix form that we want it on. 1, 0, A, 1, B, C. We want the ones to go diagonal, and we always want a 0 underneath the ones. That is our goal. First of all, let's set this up into a matrice. So this is going to become -1, 3, 8, 11. Okay? Now you see this 2 right here? We want that to be a 1. How do we do that? Well, according to one of the rules, we can multiply the second row by -2. I take that back. To get this to 1, all we got to do is divide by 2. So this is, remember, this is row 1 and this is row 2. So we're going to do row 1 divided by 2 to change. I use this arrow to mean to change. To change, we're going to change row 1, meaning it's going to affect all of row 1. All the integers in row 1 are the ones that are going to be affected. So our new matrix, if you divide everything by 2, 2 divided by 2 is 1. 2 divided by -1 divided by 2 is -1/2, and 8 divided by 2 is 4. And bring the rest of the rows. Bring the next row down. They are unaffected, so we simply just bring them down. Okay. What is our next goal? You see, there's a 1 right here. There's a 0 underneath a 1 all the time. We want that 1 to be a 0. So how do we make that a 1? A 0. How do we make that a 0? Well, there's one way. We would multiply row 1 by -1 and add it to row 2, which would give us 0. So what I'm saying is multiply row 1 by -1 and add that to row 2. And we are doing that to change row 2. Only row 2. Row 1 will stay the same. The only row that's going to change is row 2. As we did before, this changed. This is the change, the row that we are changing. So I'll just put change. So let's apply that. So when you multiply row 1 by -1, well, let's bring down the row that's not getting affected. So let's do that. Multiply row 1, which is 1, by -1. So 1 times -1 is -1, plus row 2. So row 2 is 1 right here. That's 0. Let's go to the next one. -1/2 times -1 is 1/2. Plus 3 is 1/2 plus 3 is 3.5. And what is -1 times 4? -4. -4 plus 11. And yeah, -4 plus 11. 11 minus 4, 7. This is 7. Oops, that is not a 7. Okay. So what else can we do here? You see over here, this 1, we need to get a 1. This is diagonal. We got to make this into a 1, this 3.5. I'm going to make things a little easier right here. I don't like working with mixed fractions, so I'm going to go ahead and rewrite this. 1, -0.540, positive 3.57. So to get this to be a 1, what do we do? Well, we can take row 2, this is row 2 right here, and divide that by 3.5. 3.5 divided by 3.5 is 1, correct? So we're going to divide all of row 2 by 3.5 to change what row? To change only row 2. So let us write the new matrix. Row 1 stays the same. 0 divided by 3.5 is 0. 3.5 divided by 3.5 is 1. Now we have two ones here, and that is, as you can see, they agree. And then what is 7 divided by 3.5? 7 divided by 3.5 is 2. 2 times 3.5. Yeah, so this is 2. There you go. We have our linear equation. Now I'm gonna write this in this form over here. We're gonna convert it back. So one thing to note is that these are your x values right here. These are your y values. If you had if you had a third integer, a third column, those would be your z's, etc., etc. And these are your constants. I'll just put k for constants. So let's rewrite that. So we know that it is, our new linear equations are x, because it's 1 times x is x, negative 0.5 times y, minus 0.5 y, and our constant, this line is basically like an equal sign kind of, so equals 4. In our next one, y equals 2. So we got our first answer. I'm going to write it in purple. I'm going to highlight this. We know that y equals 2. All we need is the x. So how do we solve for x? We can substitute this y equals 2 into this first linear equation. So let's do that. X minus 0.5 times 2 equals 4. What's negative half times 2? Half of negative 2. It's 1, but it's negative. Remember this negative sign. So x minus 1 equals 4. Combine like terms. We're going to add 1 to both sides. Oops. So x equals 4 plus 1. Therefore, x equals 5. There you go. So let's write our answer over here. Now I'm going to check this to make sure it is correct. If I got the correct answer, the linear equation, this should be true when I plug in this ordered pair of these values into these linear equations. So let's figure that out. So let's apply that. 2 times x minus y equals 8. Well, we know what x is. X is 5. So 2 times 5, we know what y is, 2, equals 8. 2 times 5 is 10. 10 minus 2 equals 8. 10 minus 2, 8 equals 8. And that's a check. That's correct. I'm going to highlight that in. See? And we could test the next one. It should be correct. I'm just going to go ahead and do it. X plus 3y equals 11. X is 5. Y is 2. 5 plus 6 equals 11. Is 5 plus 6 equals 11? Yep, 11 equals 11. And that's a check. So our solution, our ordered pair, is correct.